All right, and welcome back to our final homework helper for Math 1 Unit 2. This is Lesson 11, Form Follows Function. And we're going to dive right into it. So problem 1, we start with this massive table that's asking us to take two different functions and then answer the information that's down the left-hand side. So compare different characteristics of each type of function by filling out the cells of each table as completely as possible. So when we look at these equations, we've got y equals 4 plus 3x, and then we've got 4 times 3 to the x power. When it asks us what type of growth this is, it's looking for us to go through and say whether or not that's linear or exponential. You guys have watched my videos before. You guys know that I'm not a big writing in using words on the board, so I'm going to talk through a lot of this. So our left-hand equation here is going to go through, and we're going to say that this is a linear equation. There's no exponents involved. It's a constant rate of change. So this one, we're just going to go through. We're going to call it L for linear. The one on the right, y equals 4 times 3 to the x power, is there's a variable in the power as an exponent. So we know that this is going to go through and be exponential. When it asks us what kind of sequence corresponds to each model, that's saying, hey, is this going to be arithmetic or geometric? And so for this one, because we're increasing or decreasing by the same value every single time in our left one, we know that this is going to be arithmetic. And because we're looking and we're multiplying by some number consistently over and over and over again, we know that this is going to be geometric. We can make a table here for each one of them. We'll do that off on the side because that's kind of difficult to do. So as always, we've got our x and our y. We've got our x and our y. And all we're going to go down and do is we can say, let's just go 0, 1, 2, 3. 0, 1, 2, 3. Make our life a little bit easier. 3 didn't come through. There we go. Without doing negatives or anything like that. And we're just going to plug in 0, 1, 2, and 3 into each one of our equations. So 4 times each. So 8 total times. And we're just going to solve for what that comes out to be. So if I go through and I go, all right, we get 4, 7, 10, 13. Great. Over here for our exponential, if we go, we get 4, 12, 36, 108. That's great. So when we look at the first table on the left and we say, all right, find the rate of change, we're just saying, oh, what's it increasing? Every time our x goes up 1, our y value does what? And we see that this is just going to be a rate of change of plus 3. On the other hand, when we look at our table on the right, we're looking and we're saying, all right, we've got 4 to 12 to 36 times 108, and we know that this is going to be multiplied. Oh, sorry about that. Multiplied by 3. So if we were to go graph each one of these, I'm not going to do them out right now just with the limited space, but if we were to go graph them, it would look something like, and you guys have to be a little bit more specific, here to here, and over here we would go there. Please go show more work than I just did there. You guys can go through and figure out what are your x's and your y's and things like that and just plot the points and be consistent. Find the y-intercept of each function. This is going to come up a couple times today. Luckily for us, we went through and when we built our table, we selected 0 as x because when you're looking for your y-intercept, 0 goes in for x, solve for the corresponding y. So in both of these, we happen to have done them both, and they both ended up being the same thing. So we can put 0, 4 in for both of them. Now, will that always be the case that they're the same? No. Everything's going a little crazy to get there and there. Cool. So when we get back, so I told you that this was going to come up again, y-intercepts for the following equations, and it wants us to go through and solve for them. All we're doing, plugging 0 in for x. We go through, we'll go, I don't want to use yellow here, we'll go pink. Nope, we've been using pink, we'll go purple. Is we're just going y is equal to 3 times 0. So in this case, y is equal to 0. Therefore, that's what these three dots mean, our y-intercept is 0, comma 0, because we plugged 0 in for x and got 0 as a y. We go down here, we do the same thing for b. We're saying y is equal to 3 to the 0th power. Well, then we know that y is equal to 1, because anything to the 0th power is there. So therefore, our y-intercept is 0, comma 1. We plugged in 0 for x, we got 1 as a y. So we're there. There we go. All right, moving right along. Just want to make sure I didn't miss one here. No, so problem number 4. So in here it says decide which form of the equation will be the most efficient to use based on the given information. Choices include if it's linear, slope intercept, point slope, or recursive. Exponential is explicit or recursive. So we're going to go through, there's going to be a little bit of talking here and a little bit of writing from me, so just pay attention if you are having trouble with any of it. So when we look, Jasmine has been working to save money and wants to have an equation to model the amount of money in her bank account. She's been depositing $175 a month consistently. So she's putting the same amount in every time. She doesn't remember how much money she deposited initially. However, on her last statement, she saw that her account has been open for 10 months and currently has $2,475 in it. Create an equation for Jasmine. So one of the things, when I look at the information that's up there, I know here that I've got, this is going to be her slope. So right off the bat, we know this is going to be linear because she's putting in the same amount of money each and every time. So she's adding $175 a month. Other information that's in there is that on our most recent statement, so we have a point here. We have 10 as an x. She had $2,475 in there. That's her y. So what we're going to do is we're going to say, hey, we have a point and we have a slope. So we're going to choose point slope for this problem. When we write out our equation, though, what we're doing is we're going and we're saying, all right, point slope. We're going to say y. Oops. Come on. Y minus 2,475 is equal to our slope, x minus 10. Boom. Now, it doesn't even ask us to solve for this problem. It just says, hey, can we set up an equation? Can we go? So we're done. Even if we don't know how much money she started with at the moment, we're done. We don't need to worry about it. We can go through and solve for that, but we're not going to do that because it's asking for the easiest. Don't just go straight to slope intercept because that was the first thing you learned in middle school. Use what's put in front of you and call it a day. Our next piece is, let's scroll up here so that we can see. The table shows the number of rectangles created every time there is a fold made through the center of a paper. Use this table for each question. So we have this table here, 1, 2, 3, 4 as our x's, and then our y's are 2, 4, 8, 16. So one thing that we see happening here is there's a pattern. Every time our x increases by 1, which is our folds column, y is going to be our rectangles, it seems that we're doubling the amount of folds that we have, the number of rectangles that we have. So in part A here, it says find the number of rectangles created with 5 folds. So when we go through and put a 5 in here, we're going to go and say, all right, well, if we're just doubling every time, we know without doing too much math that there's going to be a 32 there. When it then asks what, oops, let's put a box around that because that answers a question. Which equation form do you choose? So in this case, we know that since we're doubling every time, it's going to go through and be an exponential. So we know that we're going to have to choose either recursive or explicit. In this case, we are going to choose our explicit. And to write the equation here, we're going to look and say, all right, not a whole lot going on. Y is equal to, if it's doubling and we started at 1, we don't have to have a first number because that would just be 1 and that's no fun when we're just multiplying by. So we get 2 to the x power. And that's going to go through and be able to have us, oops, sorry, let me do this. That's as simple as we need it to be. Now, it does ask us in part B, find the number of rectangles created with 14 folds. We can go through and do that. I actually missed that when I was doing my answer key for it. So we're going to go through, we're going to say, all right, y is equal to 2 to the 14th power. And we're going to get, this is equal to, and luckily, just keep a calculator always handy, this is going to come out to be y is equal to 16,384 folds. Awesome. So we're going to keep moving on here. Number 6. Which equation form do you use? Write the equation. I believe we did that down here. We did. All right, so that double dipped. Apologies for that. All right, so part 8 here, or problem 8. For each equation provided, state what information you see in the equation that will help you graph it and then graph it. So things that have to jump out. When we see y equals 8 times 1/2 to the n power, or to the x power, so you're somebody who needs that xy piece going on. First thing that jumps out to me is that we have a y-intercept of 0,8. And how you can go get ahead and get that is just take 0, plug it in for x, or an n in this case, and then solve for it. 1/2 to the 0th gives us 1. 1 times 8 is 8. So we have 0,8 as a point. From there, this is going to be another piece, I'm not going to write it, is that each y value is going to be 1/2 of the previous piece. And we know that from that wonderful number right there, where that's telling us, oh, we're going to be cutting our last y value in half every single time we increase our x value by 1. To graph this, I believe that it graphs on the next page, so just give me a second here. Yes, and I went ahead and preemptively put some stuff on here. So if we wanted to go do this, I have not created a table, but we'll plug this in. We know that when we plug in 0 for x, we get 8, because we just did that on the last piece there. When I plug in 1, I get 1/2 to the first is 1/2 times 8 is 4. When I plug in 2, I get 1/4. So 8 times 1/4 is going to be 2. Really, I'm just cutting things in half. Oops. And then 3. And then boom. And then we get to go connect these. And once again, I apologize for my drawing, and we'll never actually hit 0 there. Awesome. So that's the graph from the problem on the last page. It's just the graph was in the wrong spot. So we look here. We get y equals 5 times x minus 2, all minus 6. You guys have seen my videos before. I'm a big fan of putting it in point slope, so I'm going to move the 6 over just to start this problem so that I can see it a little bit more clearly. Come on. Y plus 6 is equal to 5 times x minus 2. Boom. So now, things that I know about this problem. I know that we've got a slope of 5. I also know that we have a point at 2, negative 6. Because I just pull out the opposite of what I see over in point slope. So here, I'm going to go plot that point. 2, 1, 2, 3, 4, 5, 6. I have that point, and then I have a slope of 5 over 1. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. I'm a big fan of show 3 points so that we can show that we're being consistent. But you do whatever your teacher has asked you to do. And then we're able to go from there. So we're just looking for basic things. What things stand out when we see the equation. So slope, point, great, talk about it. Y-intercept we could have done. However, that's going to be somewhere down way south on the graph. And yeah, we're just not going to go down that route right now. All right, awesome. Sorry, I got ahead of myself. So moving on to the last couple problems that we have here. There's 3 of them. Problems 12, 13, and 15. and the instructions for this is just to solve for x, I believe. And then justify your answer by identifying the properties that you used. So you're going to go through and do that. I'll talk about why I did things, and you just have to write them down. So when we look here, all we're doing is we're getting x by itself. Subtract 11 from both sides, and we're looking at x is equal to negative 27. Boom. So then with 13, we're just going to subtract 6 from both sides. We get x is equal to 4. Awesome. And our justification is we're just using the addition problem. You know, we're just going through, we're saying, all right, like, let's just do our opposite. I'm sorry, so that would be the subtraction property because we are subtracting. Then when we look at 15, we say, all right, well, we've got negative 3x equals 2. Divide both sides by negative 3 for the division property. And we're just going to be left with x is, hold up. Wow. We're going to be left with x is equal to 2 over 3 with a negative. And I always make the numerator because that's just who I am. And then we're good there. And like I said, that is through our division problem. All right, that is the final installment of our Unit Math 1, Unit 2 homework helpers. If you have questions, please talk to your teachers. If not, I hope you all have a very, very pleasant day.